Good morning. This recording is for Pre-Algebra Chapter 4, Lesson 4, Simplifying Fractions. But first, a quote from the mini snicket, Horseradish Bridge Shoes You Can't Avoid, page 67. One of the world's most tiresome questions is, what object would you bring to a desert island? Because people always answer a deck of cards or Anna Karenina, when the obvious answer is a well-equipped boat and crew to sail me off the island and back home where I could play all the card games and read all the Russian novels I want. Thank you, Lemony Snicket. Alright, so equivalent fractions. This should totally be review. You guys have been doing equivalent fractions since probably 3rd or 4th grade. Yeah, totally review. So, equivalent fractions show the same part of a whole. And then we need to find equivalent fractions by multiplying or dividing the numbers and numerator and denominator. It's supposed to be numerator, by the way. Numerator and denominator by the same non-zero factor. So let's go ahead and do some examples. So 5 over 15. If we were going to simplify, we would divide the same fraction by a number that goes into both 15 and 5, which is 5, and we're going to end up with 1/3. And I can take the same fraction before, 5 over 15, multiply it by 2, both the top and the bottom, and I'm going to get 10 over 30. So 1/3, 5 over 15, and 10 over 30 are all equivalent fractions. Alright, next we're going to do 10/12. We're going to divide by 2. We're going to get 5 over 6. We can take the same fraction again, 10/12, multiply it by 2, and you get 20 over 24, because 2 times 10 is 20, 12 times 2 is 24. Again, when we're multiplying fractions, it's the top number times the top number over the bottom number divided by the bottom number. So let's go ahead and do 14 over 20. So let's divide by 2. We're going to get 7 over 10. And then, because 14 divided by 2 is 7, 20 divided by 2 is 10. And we can multiply as well. 14 times 2 is 28. 20 times 2 is 40. Those are all equivalent fractions to themselves. All right? So let's go ahead and do the next one. Let's go ahead and talk about simplifying fractions using prime factorization. Now, I'm sure most of you guys are familiar with how to divide, but you're not always sure what to divide by. So here's the thing. We're not going to divide. We're going to turn this into a multiplication problem and then just cancel out the things that are in common. So what we're going to do is we're going to write the prime factorization for 6 and 8. There they are. So 2 times 3 is 6, 2 times 2 times 2 is 8, and then we're going to cancel out everything that's on the top and the bottom. So the only thing that we have in common between the top and the bottom is a 2. So what's left over after we cancel out the 2's? A 3 on the top and 2 2's on the bottom. So the 3 stays on the top, and we still multiply the remaining 2's, so the 2 times 2 is 4, and we get a simplified fraction of 3 over 4. Alright, so let's try this again with 9/12. Come up with the prime factorization trees for 9 and 12. We got 3 times 3 and 3 times 2 times 2. So the 3's go on top. 3 times 3 is 9. 3 times 2 times 2 is 12. We're going to cancel out the 3's on the top and the bottom. So 1 3 on the top, 1 3 on the bottom, which remains a 3 on the top and 2 4's on the bottom. And therefore, we do have a final answer of 3/4. Alright, something a little trickier. So let's find out the prime factorization for 28 and 35. For 28, it's 2 times 2 times 7. For 35, it's just 5 times 7. So the 2, 7 goes on top. The 5, 7 goes on the bottom. And we're going to cancel out the 7's because they're the only thing we have the same on the top and the bottom, leaving us with 4/5. Alright, so this is a very short video, but I hope you guys are very good at simplifying fractions by the end of this. Alright, so let's do it now with some variables. What do we have the same on the top and the bottom? Well, we have a b, so we're going to cancel out the b. The only thing is we've now officially canceled out everything in the numerator. Everything on the top is canceled out, but we have to have a numerator. You cannot have a fraction and not have a numerator. So, since all of the things on top canceled out, we make the numerator 1. So this is very important, right? If everything on the top cancels out, we make it a 1. But if everything cancels out on the bottom, we don't care. And I'll show you a problem about that in just a second. So the next one is 2mn over 6m. And we're going to do the prime factorization for 2 and m. Well, the prime factorization for 2 is 2. So we don't actually have to simplify that because, there's no point in having 1 times 2 there because we still have the 2. But the prime factorization for 6 is 3 times 2. So now we have 2 times m times n on the top and 2 times 3 times m on the bottom. And we're going to cancel out the things that are the same on the top and the bottom, like the 2's and the m's, which leaves us n over 3, excuse me, because we still have the n and we still have the 3. Okay, last problem is 24x to the second times y over 8xy. So we're going to do the prime factorization for 24, which is 2 times 2 times 2 times 3, and the prime factorization for 8, which is 2 times 2 times 2, and we're going to write them all out, and this is called expanded form, when I take something that has exponents and write it out with the actual number of bases that I have. So since I have x to the second, it's really like having 2 x's, okay? And then I'm going to cancel out, again, everything that's on the top and the bottom. I'm going to cancel out the 3 sets of 2's, 1 set of x's, and 1 set of y's, which leaves me just a 3 and an x on the top. Notice how everything in the denominator, everything in the bottom cancels out. And since everything in the bottom cancels out, I just no longer have a fraction. Okay? So that just leaves me with my answer of 3x. Okay, I'm done. Told you it was short. Have a good rest of your day. Bye, folks.